The next topic of the session is how to find the inverse of a function and what is an inverse of a function. So for a definition, I can tell that for a function that is f from set x to set y, there exists a function, say g, I can write it as some g, that is from set y to set x, such that g dot f of x is equal to I set. What is the meaning of this? So if this is x, this also comes to be the same value, right? Let me show that with the help of an example. Here there is one more condition along with g dot f of x is equal to ix and f dot g of y. So I am considering an input of y that is belonging to this set y. That's why identity function that is belonging to the set x is ix. Identity function that is belonging to the set y is called as iy. Right? How to find the inverse of function? So generally we need to know which of the functions are invertible. The functions are invertible if the function is a bijective function. Function is bijective. What is the meaning of bijective? In the previous sections you understood that what is a bijective function. Bijective function is the one that is both 1 1 and on 2, right? So if the function is bijective, then it implies that the function is invertible. Invertible means the inverse exists. Function is invertible. How to find the inverse of that function? That's what we are going to learn in this session now. So let me take an example for this. So let me take a function, say f of x. F of x is equal to 4x plus 3. 4x plus 3 is a function. I need to find the inverse of the function. So it should be some other function, let's say g of y, such that g dot f and f dot g are identity functions. Right? So just by seeing in the previous sections you can understand that this is a simple function and it is however a bijective function because it's a linear graph you are going to get from that linear algebraic expression. Right? So how do you find the inverse of this function? So let me name f of x as y. F of x is equal to y. So y is equal to 4x plus 3. Now I need to get x in terms of y. So bring 3 to this side, becomes y minus 3 is equal to 4x. Bring this 4 to the denominator, x becomes y minus 3 divided by 4. Right? I need to let me name this as function g of y. Therefore g of y is equal to y minus 3 by 4. So that now just we have found out based on our trial method. So now we need to prove that this function is the inverse of this f of x. So how do you prove that? So based on the definition, if f dot g of y is an identity function and g dot f of y, g dot f of x is also an identity function, we can tell that g is the inverse of f, right? So let me put this. What is g? F of g of y, right? So this becomes f of g of y is y minus 3 by 2, y minus 3 by 4, okay? Then in the place of this x, I need to substitute this y minus 3 by 4. So it becomes 4 into y minus 3 by 4 plus 3. 4 and 4 is going to be cancelled. Now it became y minus 3 plus 3. Minus 3 plus 3 cancelled. However, got y now. So what you are going to get here, it is, if you input a y, you are going to get y as an output itself. So let me check in this case also. This is g dot f of x, that comes to be g of f of x. What is f of x is 4x plus 3. So this g of 4x plus 3, I am going to write it here. In place of this y, I am going to substitute 4x plus 3 here. Right? So in place of this y, I need to write 4x plus 3. Then it is minus 3. This is in place of y I am writing this much. and this is divided by 4. So plus 3 minus 3 comes to be 0. So 4x divided by 4. 4 and 4 is going to be cancelled. So you're going to get x. So this is the function g dot f of x. That comes to be x here. Or I should write in both the cases as I y and I x. Therefore, g is the inverse of which function? The f of x function. So how can I write this? So there should be a proper notation. Notation for inverse of the function is f inverse. So say f is a function, then f inverse of x is the inverse of f of x. That's how you are just going to represent the value, that is f of x here. Right, now we'll go to the exercise. Before entering into the exercise, we'll just see into the example 25. This is a different type of question. One of these type of question is also in there in the exercise. That time I'm going to skip that question. So we have the function f of x that is defined from the set of natural numbers to the range of f. Range of f is all the numbers that can come under that function as the range. So f of x is defined as 4x square plus 12x plus 15. So how do you find the inverse of this? That is the question. So for finding the inverse, however, as done in the previous question, we did as y is, in place of f of x I wrote y, and the same thing I'm going to write. So, and at last I need to get x in terms of y. But there are two terms with x here, and I don't know what to do with this. This is a quadratic expression, so somehow I need to get it into a linear expression. For that I strike the method how that could be a completing the square method. Completing the square, that is very important. That is also very useful in solving some calculus, especially integration. So that method I'm going to use here. So completing the square. So for a square it should be a square plus 2ab plus b square, or a square minus 2ab plus b square. Right? So here we have, this is the a square term, and this is the 2ab term. So I need to get the b square term such that I need to complete the square. That is, I can write this as a plus b whole square here. I find that this is not a complete square, that's why I need to get that b square term here, right? So if this is a square, what is a? A square is 4x square, therefore a is 2x. Here 2ab, 2a into b is 12x. 2 and 12 will get 6. A is 2x. 2x into b is equal to 6x. X and x are going to be cancelled, 2 and 3. Therefore, b is equal to 3. So I need to write this as 4x square plus 12x plus 9. 9, I mean 3 square here because I want a b square term. This comes to be 9. I have added 9, so I need to subtract 9 here plus 15. Right? So this is an a square plus 2ab plus b square here. So what it can be here? It is 2x plus 3 whole square minus 9 plus 14 comes to be plus 6. Right? Now I am going to bring it to the left hand side. So 2x plus 3 whole square is equal to y minus 6. Because 6 I brought to the y side and this is I interchange the sides, that's what. So now I am just going to take the positive parts only because it is the number that is natural number, that is only positive. So 2x plus 3 is equal to root of y minus 6. So now just simplify, you have a linear equation or a linear expression in terms of x. So you have 2x is equal to root of y minus 6 minus 3 divided by, okay, if I bring this 2 next here, comes to be root of y minus 6 minus 3 divided by 2. This is the function, or let me name this as f inverse of x. So just if you find this f inverse of x, it's not enough. You need to prove that this is a inverse of the given function. So how do you prove? Based on the given definition, you have that g dot f and f dot g should be what? Okay, just let me name this as g of x, not f inverse of x first itself, because I haven't proved that this is the inverse of that function. So let me mark this as f dot g of x. What is f dot g of x? Here g of x is this function, or this is in terms of y, right? I should write y. So f dot g of y. So what are you going to get here? G of y, f of g of y. In place of g of y, I'm going to substitute f of root of y minus 6. Y root of y minus 6 minus 3 by 2. Minus 3 by 2. So now again I'm going to substitute this here. Instead of doing all those things, I can just substitute here 4 into x square is y minus 6 minus 3 whole square divided by 2 square comes to be 4, and 4 you're going to get cancelled, plus 12 into root of y minus 6 minus 3 divided by 2. 2 and 6 is going to be cancelled here. This comes to be 15. So a square minus 2ab plus b square, that term you need to write here. So this is a minus b whole square, that comes to be a square. A square is y minus 6. B square is plus 3 square is 9. So the middle term is minus 2 into a is root y minus 6 and into 3. That is the first one. Second part is 6 into root of y minus 6. Then 6 I need to multiply to minus 3 also, that comes to be minus 18 plus 15. Right? So this is 6 root y minus 6. 3 into 2 is 6. So plus 6 root y minus 6 and minus 6 y root minus 6. I'll just cancel that. So now you have with you 15 plus 9 and 18 plus 18 plus 6, 15 plus 9. This is a negative, this is a positive part. Y you have, so 18 plus 6 comes to be 24. 18 plus 6 is 24. 15 plus 9 is also 24. So this is negative, this is positive. They are going to get cancelled. So this comes to be y itself. What is y? It is an identity function which is having the range of f. That you need to mention here, right? So let's cut off this. Okay, next we have the second part of that. This will be an easier simplification than that. So instead of using this whole term, you could have just used this also. This is the same function itself, f of x itself, right? So you can, instead of using that big terms, you can directly use, so that your simplification will be easier. So in the question, if it is given, show that it is a invertible function and find the inverse, that means that directly you can write this instead of doing big calculations. Just write the first step here and you are going to get however it is. So next part is g dot f of x. G dot f of x is g of f of x. What is f of x is? Let me take this part now. Let me mark this as equation 1. So this is f of x here. This is also f of x, and unlike this one. So I will write it as 2x plus 3 whole square plus 6. G of 2x plus 3 whole square plus 6. So in place of this y, I need to substitute now that big term, that is 2x plus 3 whole square plus 6. So let me substitute now. That comes to be root of, in place of x, that is 2x plus 3 whole square plus 6. And there is one minus 6. Plus 6 minus 6 cancelled. This minus 3 is remaining. Minus 3 divided by 2. Right? So this is 2x plus 3 whole square is there. 1 square root and 1 square is going to be cancelling. So 2x plus 3 minus 3 is remaining. So plus 3 and minus 3 is again cancelling. So you have 2x by 2, that is x. Or you can write it as I and n. N is the domain, or the function to which that x is belonging. That's what you're going to mean. Now we'll move on to the fourth question of the exercise 1.3. Now we have the fourth question, that is the function given is f of x is equal to 4x plus 3 divided by 6x minus 4. It is asked to prove that f dot f of x is equal to x for all x that is not equal to 2 by 3. So it is also asked to find the inverse of f of x. Right? So this is the first part. This is f dot f. So I need to find that f dot f of x is equal to f of x. Okay. Now in place of f of x, I need to substitute the whole thing, that is f of 4x plus 3 divided by 6x minus 4. I'm going to substitute. This is a big term now. I'm going to get. I need to break my head here. So 4 into, in place of whole x, I need to write this 4x plus 3 divided by 6x minus 4 plus 3 divided by 6 into 4x plus 3 divided by 6x minus 4 minus 4. Yeah, that's a big thing. So I need to take the LCM and cancel off this 6x minus 4 is becoming a big problem now. So let me continue. That comes to be 4 into 4x plus 3 divided by 6x minus 4. So I need to multiply the 6x minus 4 to 3 also. So I need to do that, plus 3 into 6x minus 4. Now we'll go to the denominator. This becomes 6 into 4x. 6 into 4x plus 3. Then this is minus 4. So I'm going to take the LCM, that is 6x minus 4. I need to multiply that to the 4 also again here. That comes to be 6x minus 4. So this is common. I can cancel it off. So this comes to be, now we'll expand. Now 4 into 4x is 16x. 4 into 3 is 12 plus 12. So plus 3 into 6x, that is 18x plus 18x. 3 into 4 is 12, so minus 12 divided by 6 into 4 is 24x plus 18 minus 24x minus 4 into minus 4 comes to be plus 16. So I should see what we're going to get here. So big terms. 12 and minus 12 going to be cancelled. 24x and minus 24x is going to be cancelled. So 16 plus 18. 16 plus 18 is 17 plus 17. That is 34. 34x divided by 34. So you can see the numbers are same here. 16, 18, 18, 16. That's what. So that comes to be x itself. Therefore f dot f of x is equal to x. We have this proved now. Now we need to find the inverse of x. F of x, right? So what is the definition of inverse of f of x is g dot f of x is equal to x, and f dot g of x is equal to x. It should be same in both the cases. So from this statement you can understand that x is a identity function that is belonging to the real set of real numbers minus the set 2 by 3, right? So this is the same thing. So we can conclude that f itself is the inverse of f. So f dot f becomes x, right? Therefore f itself is the inverse of f of x. That is f inverse is equal to f. That's what you are going to conclude here. So if you want, you can just write little more steps to just prove this g dot f. Just to write this statement and just show the steps once more for that. So that's all for the fourth question. Now we have the fifth question of the exercise. So the question is to check whether the following have inverse or not. You're not asked to find the inverse. You need to just tell whether they have an inverse or not. So the first part of the question is showing the function f, that is 110, 210, 310, 410. So all of the given pre-images have the same image. So just by showing the arrow diagram, I can just say that there are 4 points and here there is only 1 point and all of them converge at the same point. This I can show that this is a many-one function. This is a many-one function. So for an inverse to exist, it should be a bijective function. But for it to be bijective, it should be 1 1 and on 2. Here it is many-one, not 1 1. That's why it is not having an inverse here. No inverse exists. No inverse exists for the given function. So now we have the next one, G, that is 5, 6, 7, 8, 2, 1, 2, 3, 4. Here 4, 3, 4, 2 are the images. That means only 2, 3, 4 are included among the images. So this becomes an onto function because 1 is not included among the images. This becomes an onto function since 1 is not an image of any. Not an image of any of them. Okay, therefore it is no inverse exists. Why no inverse exists? The same reason, because for an inverse to exist, it should be a bijective function. Here it is not a bijective function, hence there is no inverse that is existing here. So you have the function here h, that is from the set 2, 3, 4 and 5 to the set 7, 9, 11, 13, right? So this was given in the question. So based on this, the given function is given here. So from this you can find out that each of them have only 1. That means that it is a 1 1 function and not a many one function. The second part is that it is an onto function because all of the elements of the second set, that is 7, 9, 11, 13 are included among the images. Hence it is going to be a bijective function. It is a bijective function. Therefore it is going to have an inverse. Therefore inverse exists. So what is going to be the next question? You need to check. Now we have the sixth question. That is a function from -1 to 1 to the given. That is a set of real numbers. F of x is given to be x by x plus 2. First part is just show that it is 1 1. That is the same classical steps. F of x1 is equal to f of x2. You go on a series of steps. At last you just prove that x1 is equal to x2. Therefore the function given is f of x, that is 1 1 here in this case. So just show that, means you have to get that somehow, right? I'm going to skip that part. So you can observe that here the codomain is given to be R, and here the codomain is given to be range of f. So just by doing this you found out that it is a 1 1 function. So to make the function onto also, you are using that function, that codomain instead of real numbers, because all of the numbers are not included over there. That's why. Okay, so you need to find the inverse now. Y is equal to x by x plus 2. In place of f of x I am writing as y, so it is x by x plus 2. So how it is? So this becomes x is equal to xy plus 2y. So now I need to bring the x terms together so that I get a common factor something. So this I need to bring to the left hand side. It becomes x minus xy is equal to 2y. So x is common, x into 1 minus y is equal to 2y. So x is equal to 2y by 1 minus y. Let me name is that g of y. I need to just prove that g dot f of x is how much? G dot f of x is g of f of x. F of x is x by x plus 2. X by x plus 2. I need to substitute in the place of y over there. So that becomes 2 into x by x plus 2 divided by 1 minus x by x plus 2. That comes to be, here it becomes 2x divided by x plus 2, and this becomes x plus 2 minus x divided by x plus 2. These are simple steps. Again and again I'm going to do this. what did I get here? X minus x and minus x I am cancelling. X plus 2 and x plus 2 I cancelled. So this becomes to be 2x by 2, that is x itself, or I, and the domain is here minus 1 to 1. So I need to find out f dot g of y, that is f of y, 2y by 1 minus y. I'm writing smaller. This comes to be f of so I need to substitute in place of that. So that is 2y by 1 minus y divided by 2y by 1 minus y plus 2, that is 2y by 1 minus y divided by 2y plus 2 minus 2y. So 2 into 1 minus y I am going to do. So this is 2y and 2y is going to be get cancelled, and you have 1 minus y. 1 minus y in both the denominators I can cancel. This comes to be 2y divided by 2, that is y itself, or you can write it as I of range of f. Range of f. Hence just by seeing this two, you can just tell that g is the inverse of x or f is inverse of g. So now next we have the 7th question. 7th question is the same question as that example 23 that I have already shown. The 8th given question here is given function f, that is from R0 plus, that is all the non-negative integers and all the real numbers also, real numbers, right? So that is to 4 to infinity. That is the given codomain. That needs to be the range also, because it is going to be invertible function. So we have the first part of the question to show that f of x is invertible. That's what you need to show, that it is 1 1 and on 2, hence it is invertible, right? 1 1 and on 2 you have already learned the previous exercise, and that's why I am not going to repeat that again and again. We feel bored that. So you need to know, next part of the question is to show that this f inverse is the inverse of the given function f. So for that f dot f inverse of y should be y, and f inverse dot f of x should be x. So like that I need to prove now. So f dot f inverse of y is the first part. So I'll rub this much here. So f inverse of y is how much? F inverse of y is given to be root of y minus 4. So in place of x I need to substitute that. That comes to be root of y minus 4 whole square plus 4. That comes to be square root and square is going to be cancelled. That comes to be y minus 4 plus 4. Minus 4 plus 4 is y already. That's what it comes to be. In identity function that is belonging to this set, that is from set 4 to infinity. Okay, this is the first. Next you need to find that f inverse dot f of x is x. How much is this? So that becomes f inverse of f of x is x square plus 4. X square plus 4. X square plus 4 is now we need to substitute x square plus 4 in place of y. So that comes to be x square plus 4 minus 4 root of that. So plus 4 and minus 4 is going to be cancelled. So x square and root, that comes to be x itself, or I can write it as an ix. X is R0 plus in this case. That's it. Next is the 9th question. That is a similar question I have already explained in example 25. That's why I'm going to skip it. Now we'll move on to the 10th question. Now we have the 10th question. The 10th question is given a function that is from set x to set y. You need to show that the function f has a unique inverse. It has only one and only one inverse and not more than that. That you need to prove. So let us take the contradiction method. That is, first you need to assume some wrong thing. You know that it is wrong, but still you need to assume that. At last bring the contradiction such that you tell that your assumption is wrong. So suppose G1 and G2 are two inverses of the given function, that is f. So both G1 is from set y to x and G2 is from set y to x. So if they are the inverses, based on the definition, you can tell that G1 dot f of x is equal to ix. That's what you infer from the given definition. And similarly, G2 dot f of x is equal to the set identity function of the set from the set x. So right hand side of both of them are equal. That comes to be G1 dot f of x is equal to G2 dot f of x. So you can see that all the remaining parts are equal. That implies that G1 is equal to G2. Therefore, f has one and only one inverse. Only one inverse in every case, whatever it is. So it cannot have more than one inverse. That's what you have proved here just now. Right? Now we'll go to the 11th question. Now we have two similar questions, that is question number 11 and question number 12. I have taken together because they are similar. Both of them have the here to show that f inverse of f inverse is f itself, right? So now we have the first part here. Here you need to find another function f inverse such that it is inverse of f. So let me name it as g. I'll just make this ulta. That is the inverse, right? And b comma 2 and c comma 3. So I need to explain how did I get this. Here it is given that f of 1 is equal to a. Therefore I can write the ordered pair 1a belongs to this f, and f of 2 is given to be b. Therefore 2b is one of the ordered pairs. F of 3 is equal to c is given in the equation. So 3c is also an ordered pair that is belonging to the function f. So I just inverted that so that I can find g here. This is a g function. I need to prove that this is f inverse. So f that is equal to f inverse. F dot g is equal to, so here I do not have a particular case, that's why you need to get both of them, all of them, f dot g of 1. So here the input is a, b, c, right? So it is a, f dot g of b, f dot g of c. You need to find out. I'm not going to write all the steps here. So this is f of g of a. What is g of a is 1? G of a is 1. So when f of 1 is a, that's why I'm going to get a itself. Similarly I get b and c here also. So here you have g dot f of 1, g dot f of 2 and g dot f of 3. G dot f of 3 you are going to get here. So similar in the previous case, here you need to find g of f of x. So first you need to find f of x. F of x is f of 1. So f of 1 is a. So this comes to be g of a. G of a. G of a is 1 here again, because a1 is one of the pairs here. That comes to be 1. Similarly you get 2 and 3 here. Therefore f inverse is equal to g. See, since f is invertible, g is also invertible. G is also invertible. G, I mean by this, it is f inverse. So f inverse is also invertible. The inverse of f inverse is therefore f. That is f inverse of whole inverse is equal to f. That's what you just proved there. Right? We are going to the next part now. Here it is a general statement is given. Here that is the function f, that is from set x to set y. First you need to get let the inverse. You need to give some assumption and just prove that it is correct. However, assumption has to be correct here. So let f inverse be the inverse of f. I'm just writing some statements and all, inverse of f here. So what do you mean here? F dot f inverse of x is equal to ix, and f inverse dot f of x is equal to iy. Sorry, it's the opposite case, I think. here it is x, and here you will get the y term, because input of y is from the set, input of f inverse is from the set y. So based on this I can just tell that this is true, right? Therefore f inverse is the inverse of f, and vice versa. Therefore inverse of f inverse is also f, right? So how did I get this? I'll just explain once more. I think this is a bit confusing here. So here you proved that f inverse of dot f is iy and f inverse dot f is ix. That's what you find out. So how do you find the inverse of f inverse? Here you found if f is the inverse of f inverse, then f dot f inverse and f inverse dot f, right? This and this dot this should be the identity function. That's what you have proved here based on the given statement. That is, when f inverse is the inverse of f and these two conditions are satisfying, that means then these two conditions are also satisfying, right? So f inverse of this f inverse function, f inverse is a function now, the inverse of that will be f here, right? Now we have the MCQ questions. Let me do that fast, right? Okay, let me rub only this much. So now the 13th question, you have f of x is equal to 3 minus x cube whole power 1 by 3. What is asked in the question is you have to find f dot f. What is f dot f of x? So for that I need to find f of x, that is 3 minus x cube whole power 1 by 3. That is I need to substitute this whole term in place of this x. That comes to be 3 minus x cube whole power 1 by 3 into this cube is 3 here, and the whole thing power 1 by 3, right? This becomes so complicated. No, it's okay. 3 minus, okay, 1 by 3 into 3 cancel, this becomes 1. So this is 3 minus 3 plus x cube power 1 by 3. So 3 and minus 3 is cancelled. X power 3 into 1 by 3. So 3 into 1 by 3 is okay. This comes to be x. X is what is the answer? That comes to be the option C. That is option C, right? Now I'll go to the last question. The question is given to me. You need to find the inverse of that question. Inverse of the function given over there. The function is f of x is equal to 4x by 3x plus 4. 4x by 3x plus 4. So you need to find something. So y is equal to 4x by 3x plus 4 cross multiplication. That comes to be 3xy plus 4y is equal to 4x. So I need to bring the x terms together here. So 4y, let it be here itself. That comes to be 4x minus 3xy. So I need to take x common outside. That comes to be 4 minus 3y. Therefore x is equal to 4y by 4 minus 3y. That is the function g of y, that is equal to f inverse of y. That is the inverse of the given function. And what is the answer here? That is the option B. The next topic is about binary operations. That I'll teach you in the next class. Thank you.